cases or usage of and the passenger is different there. So that's why we have individual systems being designed. Like for example, if you take a bike rider, it would be a very small, because the size of vehicle itself is small, and features would be different. There the rider would be associated with, I mean, he has been interested in different features. Then you come to car, it is different. Then when you come to like what I have displayed as a bus or a truck or minivan, there the interest would be different, because the crowd that we are addressing would be different. Like in a truck, if you say it is just a driver who is who might be interested most into safety features, like how his truck would take a turn or something like that, and for his entertainment. When it comes to bus, we have to address both the driver and the passengers, so that the passengers, if it is a long drive, then we have to address to the passengers entertainment as well. So that's where the different systems have evolved. So professional systems are something which deal with the commercial vehicles, like I told, the bus, trucks or minivans. So professional systems are meant for these kind of vehicles. There are different kinds of professional systems. Like one is coach infotainment systems, which is mostly used for the coach buses. And there is one more solution which we have is V2X, that is vehicle to everything. So that has an kind of facility to exchange the data between the vehicles surrounding it. And the other one is a digital mirror, where we replace the side mirrors with the interior we replace the side mirrors with the cameras, but the view would be seen inside the vehicle. And there are many other professional systems which help these drivers to have a smooth travel, but these are some of the solutions which I have listed, which are related to HMI domain. Okay. Any questions here? Okay, move to the next slide. So we'll start with the coach infotainment series. So why we have picked this for a professional system is, like, this is a bigger set of system which is available, and sub of these features or systems would be used in different use cases. Like this is for which I'm going to explain is for a bus, a double decker bus. So it will have its driver space, a passenger space. So out of this you can derive for a truck where it will only have a driver space. You can derive to a single decker bus where it will have driver and one decker bus. So this is a super set, I can say, and these, out of these we can derive to other professional systems. And race entertainment is again related, because passengers are something which would be related to a race seat entertainment system. So what do we mean by coach infotainment series, or we also call it as media infotainment series? So this is a system which help so for the driver, he will have access to complete bus systems, and passenger would have a kind of living space experience whenever they are traveling. You might ask, what is the need for these kind of systems? Okay, we generally in our Asian markets, we haven't come across these kind of systems, but these are very much common in been there for very long time in Europe and especially North American continents. So this use case would be like a bunch of people traveling, or a bunch of people traveling along with a friends or family for a very long trip. Or this could be used by the tour guide travel systems, where they take multiple people to the same destinations, but they want to give a good experience to their passengers. So that's where this market is there. So, but we don't see much of it in Asia. But yeah, as I told, it is much of in North American and Europe region. So how does this work, or what is the architecture as an at a very bigger level? What do we have? Okay, what how we divide, or how do we understand this is, one, we have it as a cockpit region. So cockpit region is mostly for the driver space, and if we assume this as a double decker bus, then we would name it as cabin A and cabin B, or a lower decker or and a upper deck. So it is like cockpit. The driver will have different use case. He will be more of to see, like if we have different cameras attached to it, how what who is entering where, all that kind of features, like and connecting Bluetooth, taking calls for himself. Then navigation is a major feature that we have. How to travel, all that related features would be there in the cockpit. For the passengers, we would allow them to connect to Wi-Fi, TV. Then, if we have cameras connected, then what is where we are, so he can stream through the cameras. All these mainly entertainment kind of features would be available in the cabin A and cabin B region. So I would like to share one video so that you can connect to what I'm trying to speak here. Just let me know if you're also, if this is audible for you also. Is this audible, Nasaya?
Yeah, it's audible, Pushpa.
Yeah, yes, ma'am. Yes, ma'am.
Thank you. Okay. So this could be a cockpit region. Yeah.
Coach travel is increasingly being measured in terms of the.
So this is the passenger is using an Wi-Fi with his own device.
Entertainment available on board, but the days of turning the radio knob while driving the coach or pushing a search button on the onboard entertainment system are numbered. With the help of the DVB-T tuner on board, your trip is even.
So this is one media glass where a TV could be played or a video could be played, map can be seen, camera streams can be seen.
More entertaining. The whole coach can follow a television highlight or that championship game you would have missed while traveling. With a CAN connection, the DVB-T tuner can be integrated into the coach infotainment system and controlled via professional Line 3. Thanks to 4 antennas and the system's diversity, the DVB-T tuner offers your passengers optimal reception while they lean back and enjoy the ride. And it is easy to connect additional video and audio sources, which opens up a rich variety of entertainment. Always ready when you are, and always providing the best reception. The BOSH DVB-T tuner is a top quality system component for use in professional coach infotainment systems or standalone operation. Just remember, you travel better with the DVB-T tuner from BOSH on board.
So this is a basic understanding of how a cockpit would work and how the cabin regions are separated. Yeah.
Hello.
Yes, ma'am.
Ma'am, one question, ma'am. Ma'am, you told that Wi-Fi is used. I mean, their own Wi-Fi they need to install and they have to use the Wi-Fi.
No, I'll just. Yeah, there are many multiple subsystems which are available, which will allow the passenger to connect. So I'll explain it in the next slide.
Okay, ma'am. Yeah, thank you.
Thank you. Okay. These are some of the subsystems which allow the driver and the passengers to make use of different features, and this is how it is. This is how these are connected. So I'll take one by one. The more explanations are there in the coming slides. Just a brief I would give it over here, how it is connected. So the main media center that we see it in the driver space, which handles most of the HMI screens, what to select and all. So this is where, this is the media center which is taken up at the, which you can see in the driver space. We have control panel where you saw multiple keys. where he was changing the screen and all. So that is a control panel that you can think of. Then we have amplifier. So this is a main subsystem which handles the power unit for which power for complete system. And also if you can see many arrows are coming in and out from this system, so this is kind of a powerhouse for the complete all the systems as well. And glasses, so we normally call it as media glasses. So glasses where we actually stream our videos and show a map, all that part. Then camera ports, yeah, camera port is a subsystem where multiple cameras are connected, and we can also connect a USB connection and then a HDMI connection, and we can also have a CV based direct connection from the media center to the camera port. And then we have HDTV for our TV feature, and then we have the router. So router is where it is responsible for having the Wi-Fi connections and some USB connections. So there is a difference between having a camera port in a camera port USB and a router USB. So some routers are specialized where they allow even the encrypted encrypted USB files, encrypted files called DRM encrypted files. So that's the difference between the camera port USB and router USB. And if you see, all these are connected through an OABR. So OABR is nothing but your Ethernet connection. So all these communicate through your OABR connections. Everything is through the Ethernet connection. And how control panel connects with the media center is through the CAN. And there is one more protocol which is RTP used for the map feature. And we have speakers. If you see, amplifier handles the cabin speakers, so whatever is heard in the cabin is through the amplifier handles it, and whatever we hear it in the driver space, it is heard in the cockpit speakers. Then we have mic. So if a driver has an announcement or something, so that mic is connected to the media center at the driver space. And we have mic 2 and 3. So if we take an example of an tour guide use case, so each decker might guide might want to announce a different instructions to the passengers. So in that case, we have mic 2 and mic 3, which are again handled by the amplifier. And some use cases where you have a kind of setup in the bus where you have a kitchen, or even maybe just a two-decker bus, then there also the intercom connection is there, where one phone is placed in the media center and two other phones are placed in each of your decker. And on the media center, we have USB hub as one more system where where the driver can connect his smartphone or a USB connection. Okay, then power. Yeah, power is what I told. This amplifier is a kind of a power hub for all the units. And cabin out is nothing but the audio cabin out. So if I'm selecting anything in the media center for the cabins, then it would be given to amplifier, and amplifier will take it to the speakers. Okay, I'll just move to the next.
Ma'am, this architecture is a fixed one. Yeah, this architecture is a fixed one, or it can be varied, because it looks like all ICs. It should be an
Yes.
IC integrated.
Yes, this can be varied. Like it depends on the manufacturer. Like he doesn't want to give a feature of HDTV, then this block would be gone. And if he wants only one port for the router, then there'll be only one port of in the USB. So it is all it can be changed. It can be changed, but major communications remains the same.
So this IC, manufacturing also is based on the the demand. I mean,
Correct.
the customization.
Correct. Correct. And
Okay.
even I said like glasses, right? So I've just mentioned about two glasses. It can be one for each passenger as well, or maybe just one for the complete bus. So if you see, I've just given an open-ended arrow because this can be cascaded. So even this is configurable. What remains the same would be amplifier, because this is the main system where it's handling the audio output and power for all the systems. And media center at the driver space, because this media center is the main thing which is handling all the features for all the systems. And control panel, yeah, again, it is a much needed kind of system. So at least these three would remain permanent, but other are all configurable and plug and play kind of systems.
Thank you, ma'am.
Okay. Any other questions? Okay, I'll just move to the next slides. Okay, it's just a small explanation of what I told over here. So we have cockpit zone. So communication between control panel, and the vehicle media center would be through the CAN, and then we have internet connections through the for the cabin communication. That is, we have a point-to-point connection, and through in this use case, only a star and daisy chain kind of connection is possible. And then we have AVB protocol being used for audio and video transmission. Possible zones are, yeah, as I explained, cockpit and cabin A and cabin B region. Then cabin B region, what we do is we offer video and audio contents and DRM content as well. And then yeah, for an infotainment sources, it can through media center could be a map. Then router, we have DRM USB and without DRM USB. HDTV is for TV signals. Camera ports is for DRM free content of USB. Then HDMI connections. Then protected HDCP protected content for HDMI. Analog cameras and IP cameras are supported in camera port. Okay. This was about the architecture part. So I'll be starting with each component. What is the feature that we provide and how it works. So I hope there are no questions now. Okay. Okay. A media center. So this we normally call it as an head unit and cockpit region. And this is a main unit which handles what features have to be enabled, what feature has to be shown, what is complete transition kind of handling is done at this media center. So if you see, I have two screenshots placed here. So if you see, one first screenshot has media, navigation, phone, camera screenshot, wherein this is for kind of a cockpit region. And second screenshot, you can see this is for the cabin region. So it has radio, camera, and map out. So, and how normally we, as an HMI use case, if I take how the driver would also know that if I touch in this button, how it is related to cabin, and if I touch a button over here, that it will be impacting in the cockpit region. Is like one small difference is this dots that you see and the color that you see. That's how we can also differentiate that I'm in a cabin region or a cockpit region. So we have differentiated through a green kind of, and next cabin would be a different color. So coming back to media center, yeah, we have different features which are available within media center. Yeah, one would be the radio. So sorry, one would be the radio, where AM, FM, all HD radio, SXM, like based on the place where we are handling this or placing this unit depends on that. Like for example, German, like Europe will have a DAB, whereas North American would have an SXM band. So it all depends on the place or the region where we are taking this unit. And then a media player, it can have USB connection, iPod connection, Bluetooth connections, and browsing of all the files, folder structures, metadata, metadata in the sense the title, artist, all that can be seen. Then playing of the songs, pausing, fast forward, rewind, then just streaming through the song, then the video files playing, all that will come under your media player module. Then phone related, we will have Bluetooth connection. So the driver can connect his own phone to the Bluetooth of this, and then he can handle the call handling, all the handling like receive, conference, all that, and the phone book, messaging and noise cancellation features are available in the phone module. Coming to navigation, why navigation is so big is that we are talking about the professional system, so the kind of vehicles that you're dealing is different. If you see, there'll be many restrictions in other continents. If you see, there will be many restrictions for a vehicle to take some tolled road or a small lane or something. So it's very important for us, if we want to suggest a route for a destination, it is very important that we know what kind of vehicle we are taking into it. So navigation features helps in all of that, considering all the vehicle attributes. So because this, we are talking about trucks or buses over here. So what other things navigation supports is destination entry, then speech dialogue, where we want to go, then speller, intelligent speller, it can tell, it can predict what next character we can put in. Then the address book and POIs is a point of interest. So if I want to go to a restaurant, you can just search for restaurant on your way. So all that can come in over here in the navigation module. Then signposts, then location, traffic message, location codes, then speed limits for all the these kind of vehicles. Then commercial vehicles, there will be other needs where we can park or something. All that would also come under the navigation module. Then it could also give the overview map, generalized map. Then text to speech, voice maps. If he is not able to, if you want to concentrate more on the road, we can also enable the voice notes for it. Then like vehicle attributes like vehicle type, length, all this is considered for any location or the route to predict the route or something. Then 3D models are also available in the map. That's a common thing which we have even in the passenger cars. Next important thing would be restrictions which have to be taken, like speed limits, U-turns, penalties if we are taking it to a small narrower road. Then certain parts there will be restrictions. So navigation would help. Navigation module would help in that. Vocal alerts would be for your any messages like traffic messages or alertness, like restriction messages. Those warning sounds and messages can be handled. Other one is it has its own, Media Center would have its own internal gyroscope. So this will help to have the navigation still on, even if we are losing the signals in between, like in conditions of mountains or something. So even that case, the navigation would not stop. It will still be ongoing based on the gyroscope that we have, based on the sensor of that. And then how do we update any map data? Like if there's a new map data available or something, it can be done through the USB. Secondary map output, the last line is nothing but whatever, if driver have put like for example in between from Bangalore to Chennai, then and in between he wants to share that map, ongoing map status to the passengers as well. Even he can do that. He can show it from his media center to the media glasses where passengers can see. So how do we that feature we call it as secondary map out, and that is done through the Ethernet connection. and the standard protocol used for it is RTP. So this is about the navigation. Okay, we have other features which are in Media Center. One is smartphone integration, so we can connect your Android Auto, CarPlay for Apple phones. Then we have speech recognition, so it can help in taking in your speech dialogues like play certain songs, or for navigation, locate to a certain place. So speech recognition is possible. Then in audio, in audio engine would have it will be handling for all the it will have three syncs, like for example cockpit speaker and the cabin and the private mode, and then and one driver announcement, like mic 1 would be handled under the media center itself. Private mode, okay, private mode is something driver has connected his phone, and he wants to listen. He's connected through a Bluetooth, so only when a call comes, only he wants to listen to that call. So what he can put it into a private mode, so that voice would be only heard only to in the cockpit space, and not to the other regions like cabin A or cabin B. So that is what we meant by private mode speakers. Then software update, software updates. If we have a next version of software update, it is done through the media center. It is not like it is for all the systems in the CIS, like even router and everything. The software updates can be done through the media center. It is not to the individual hardware, but it will be done through the media center. Intercom, like what I explained, intercom will have all the basic call handling, accept, reject, and adding to a different one more call. So this is what the intercom. So this handling or the control is there in the media center screens. And then camera control, camera control, like I showed you the cabin screenshot. So where the driver can select any cameras he want to see, and if you want to show it to the passenger as well. So that control we have it in media center. So it handles the camera streaming for all the zones, and also the rear view camera for rear view camera for the vehicle, that is also supported through the camera control. Then map out, secondary map out is if you want to show the map to the passenger. And then external media, it is handled through different subsystems. One is our router, then it will have USB 1, USB 2, and internal storage. It will have its own internal storage as well. Then other sources would be camera port. Also we have USBs, HDMI we have to the camera port, and HDTV, AV1 and AV2 streaming. So these are external media player, like not directly connected to media center, but connected to different subsystems, but can be controlled through the media center. Okay, I'll also complete this component, then maybe I'll take the questions. So okay, control panel, I've just shown just one simple control panel. So here if you see, there's a cockpit and the cabin, and there are multiple buttons over here. So why this, there is a zone division in even here. So if all these buttons, what you see, okay, even this connects. So all these are for the cockpit, and rest are related to the cabin features. And how do we differentiate in the real time is there are actually, these are illuminated keys. So like I showed the color differences. So cockpit would always come up in purple. These buttons would be illuminated in purple, and cabin buttons would be illuminated in their respective colors. How do we change between cabins is, again, a press on this button would change between two cabins if there are multiple cabins. And each button I'll not explain, and how this control panel, how like if I press on it, how it gets impacted is like if I press, I'll take an example of cockpit. So if I just rotate this is for the volume change. So if I just rotate it, this would be connected to, like I showed, it is connected to media center via the CAN. The information would go to the media center, and media center will take a call, because it is pressed on the cockpit button. It will increase or decrease the volume at the cockpit region. Like for example, if I change the volume at the cabin, this button, then even now the information would go to the media center. Then media center knows that the cabin button is pressed, so it will take a call, and it will send the cabin out information to the amplifier, and then amplifier will handle the speaker change volume. This is what is also written over here. Like we have separate volume controls and quick access to basic menus, and visual indication is there, and automatic switch over to cockpit mode. Okay, if I had pressed any cabin and I quickly want to go to the cockpit, then I can just press this home. So even the screen in the media center would change. Okay. These will be the next subsystems. I'll quickly show one more video, like whatever I said here, how it's going to impact. Then maybe you'll have more understanding.
Coach Infotainment Series. Intuitively operated via touchscreen, panel, or voice control. The system has DAB+ radio, USB audio, and Bluetooth audio streaming. The integrated navigation system calculates bus-specific routes using commercial vehicle attributes. Navigation and intermediate destinations can be set within the current language region using the current national language. Telephone functions or other features in the cockpit also work via voice control. The points of interest stored in the navigation can be targeted specifically. By pairing the mobile phone via Bluetooth, you can receive up-to-date traffic information directly in the system. Bluetooth audio streaming can also be operated by passengers. The driver can restrict the output of certain audio signals, for example route information, to their hearing range by using private mode. Via HDMI input, the travel companion supplies individually created content to guests on the full HD passenger monitors. In addition to the driver's microphone, up to 2 concierge microphones can be integrated.
So this is a real-time example where this system is actually placed. So Setra is one of the bus that is introduced by Daimler, and we have this system in the real-time buses. Currently, the version that you saw is on the Europe variant, but there are also buses in the Mexico as of now. That's how the features are controlled from media center to the passenger, and that's the impact that we see at the passenger level. So I'm continuing with the other next components, like it's all subsystems, each subsystems. So if you have any questions here for media center, I can take up.
All this infotainment system, do they have separate ECUs? How are they controlled, madam?
Yeah, like I said, these are individual subsystems, and each one of them are connected via the Ethernet. Like I told, amplifier is one main unit which handles the power part of all the subsystems. And if you see media center, what I explained there, that will handle the features that are that can be enabled from each of them. So these are all subsystems. All are connected through an Ethernet, and that's how the data flows between each of these systems. Does
Do
that
they have
answer?
any simple, do they have any single control, or how is that, how do they communicate each other?
Okay, I think I'll go back to the slide. Okay. If you see if you see this cabin out feature, right? So all the screens that you viewed in the video, right? So all the screens and the feature selection happens in the media center, that is at the driver space. Even for the cabin, that means the passenger side also, if he says I want to play a USB content from the which is connected at the camera port, what he does is he goes to the camera port screen in the media center. It will have and it will be listing all the songs which are there in this USB of camera port. Okay, then he will select one of the video song from there. What happens is when it selects it, this media center tells to the amplifier that something has been selected that should be played in the cabin. Yeah, then amplifier will take a call if it is a video or an audio. Okay, and if you see there is an OABI connection from the camera port here as well. Yeah, so what it does is it takes the info what is being selected, it will take the information, it will try to play in the media glasses, and it will try to play it in the speakers. So selection happens over here. What has to be played and what is the content is handled in the amplifier. What goes where will be taken by the amplifier.
Okay, ma'am. Okay, thank you.
Hello, ma'am.
Yes, ma'am.
What is the frequency range, ma'am, of that amplifier?
Okay, it depends again. I cannot give a specific thing because it depends again on the type of system, type of vehicle that we are handling. So, and it also depends on the manufacturer. What depends completely on the configuration that they would ask for. So there's no one set of configuration available.
Okay, ma'am. And the type of amplifier also depends upon the vehicle, ma'am, or applications,
Yes.
or how?
Yes. Yeah. But like at least one kind of I would say one pre or which is available for all vehicles would be defined as like what is the kind of communication that we are doing through the amplifiers. That is one thing. Like here, mostly nowadays everyone is going with the Ethernet kind of communication part. So that would be a common thing. And ports, like what subsystems we are attaching to it. It depends again on the ports would depend on that.
Okay, ma'am.
Amplifier is again connected via the OABI for all the subsystems, and through the Ethernet itself we are handling all the audio video streaming, and for all the mic control and the configuration diagnosis software update, it is handled through the Ethernet connection. And then intercom, we have the analog audio and serial port for the intercom systems. So intercom is directly connected to this amplifier subsystem. Then amplifier, okay, we can have the microphones for the cabin region. Then it has acts as a power supply for all media center, battery connections, ignition, reverse gear, all basically of complete power hub for all the systems. And this supports the analog stereo for the cabin speakers. So this can change, like what I told, based on the requirements. Glasses, glasses is nothing but what we seen in the cabin region at the passengers. So currently the system that I have shown to you in the video that I'm explaining, has no touch inputs. It is just a view. So actually, passenger cannot control what he can select here or what he can see. Only in case of TV, he can control through a remote, but other features like camera or map or any video played from the USB, passenger doesn't have any control. He'll just be viewing this media glass, and the media center where the driver can actually select what can be viewed in this glasses. Yeah, and these glasses, yeah, are internally and to the amplifier are connected through the Ethernet. And these are like a cascaded kind of glasses, and it also has its own it will allow the AVB video, and it can have its own configuration diagnosis part, software update for each integrated switch is nothing but map or something. So that can be there's just one hardware switch to it, and then it will have two syncs, that is video streaming and camera streaming. So video is a different kind of content that is coming in, camera is a different kind of content coming. So this glass will have a software which will allow both the kind of streaming. And there can be multiple size of these glasses, and it again depends. All glasses can have similar content or the same content, or it can also be configured that one decker can have different content and second decker can have, upper decker can have a different content, or it is only one decker but two rows of glasses are there. So one row will show a different kind of content, maybe a USB playing, other row would show a map output. So these content which are shown in these glasses also are configurable, and will be, but content which is displayed will be controlled in the media center. And we have camera ports. Yeah, this is one subsystem which will again be connected to the amplifier through an Ethernet, and we have multiple kinds of cameras connected here, multiple types in the sense the analog and digital cameras. Why the need for both kind of cameras is like normally analog cameras are used, for example, if it is a two guide kind of use case, and cameras would be placed outside the vehicle, and the guide wants to without opening the windows, if he wants to show what is the actual view outside, so they can select the surround view camera, which are analog cameras. So it will show what is actually there outside the vehicle without even opening the windows. So that streaming, such use cases, this analog cameras are used. IP cameras or the digital cameras are for the security cameras, like CCTV cameras, which can be placed at the doors, so that driver can monitor who is getting in, who is getting out, or within the buses or the coaches, where he can monitor one security camera. So there's a need for these two kind of cameras. So this subsystem camera port will handle both kind of cameras, and we can handle the split screen mode. So this allows the streaming of both kind of cameras parallelly as well. So along with the camera handling, it has an HDMI port, so we can have an HDMI content played through other systems. We can connect through an HDMI, which is this, and we can have the HDMI content played. There's a USB port as well, which can allow us to plug in USB and play the contents from there. It need not be that only one camera port be there, but it can be, we can connect multiple camera ports as well. which is again a cascaded formation, like how we have it for the glasses. We'll go to the next one. Router. Yeah, router is one subsystem mainly used for the Wi-Fi features. So we have it would have an LTE modem for the internet. It also allows video streaming through an USB, which is a DRM, which supports the DRM encrypted. So again, this router subsystem features of it would again depend on the configuration that a manufacturer would be required. But this is a standard kind of routers in such kind of systems that we get. It will also have its own streaming output stream that it can have, then the configuration and diagnosis and software update for this system. Next one is HDTV. Basically for all our TV signals, it will come along with our station name, and we can change the station, and we can handle the diagnosis software part, update and all. And it is again connected to the Ethernet. USB hub is something which is connected to the media center. So this will allow all the smart devices like smartphones to connect to the media center. And this is an active hub of either 24 volts environment. This can also be used for charging our USB devices as well. This is about the components, individual components. Any questions I can take up? Okay, I'll take it for, okay, we have reached already 3 o'clock. Okay, Ethernet and AVB support. Okay, if you see automotive history, we have been using protocols called CAN or MOST, FlexRay, etc. These kind of protocols are used previously, but as we evolve and with all the bigger data to handle, even we have automotive industry is using Ethernet here, so that we have a larger bandwidth, and we can handle a large data flow. So that's where an automotive Ethernet comes into play. And normal Ethernet is different, and automotive Ethernet is slightly different. It is much cheaper. Normally, the Ethernet that we use in our homes or in offices is it will have two twisted pairs of wires for transmitting. So one is used for transmitting and one is for receiving. But whereas in automotive Ethernet, what happens is it is having only one twisted pair. So only that one pair will handle the flow of the data. And even the length of these wires would be very less, because the size of vehicle just depends on the size of the vehicle. So other standards which are used for Ethernet, for automotive Ethernet, are 100 base T1 and 1000 base T1, so that it can handle 100 Mbps of data. It's still evolving. So as we go, as we are talking also, it is just we are still it's just expanding its bandwidth. So a large data can be handled by taking help of Ethernet, because playing in video, playing in camera streaming requires a much bigger bandwidth of a network. And talking specific to AVB bridging, why I wanted to take up this was, initially what happened when this kind of handling of videos and audios were taken. There were no set standard of rules that someone has to encrypt a video in a certain format, and it can be placed into other system which can play it. So there were no set standard of rules set before. So altogether, what they have done is to IEEE organization. What has done is they have set a protocol called as AVB. So this is audio video bridging, so that everyone, whoever wants to enter into automotive domain and wants to handle these audio and video, everyone has to follow this AVB set of rules, so that each system can decrypt and play or handle these files. So this was a protocol which was built, taken up or set by IEEE, and everyone across world follows these protocols to handle the audio and video files. Okay. Some use cases I think I have covered mostly in of these while explaining. Some media amplifier use cases would be, you have to hear in both cabin and cockpit region. So that is two different kinds of audio sources for an amplifier. Intercom can be can be placed in different zones. Then private mode that we saw in video as well, that if a driver wants to hear to his call only to himself, then he can set it to private mode. Then amplifier, different kinds of video is also handled here. Audio and video streams can be handled, and mic announcements can be handled. Then routing amplifier will also handle the audio routing, where which audio has to go to where based on the selection. Then even router, we can have multiple routers. If, like for example, 2-decker bus, each one router at each decker can be placed, so that the Wi-Fi connections is stronger, and they will have it's their own bandwidth. So, and video in cabin, glasses will help us out in having the video streamed in the cabin regions. So there are basic small use cases that I've just put it down here. Okay. The last, this will be the last slide. So security plays a very major role, especially in these kind of systems where we are handling multiple set of multiple devices. First of all, system itself has multiple subsystems, and connections connecting like external devices connected to these subsystems are multiple. Like we are having multiple USB ports, we are having internet connections, we are handling mic connections, we are handling camera ports, and we are handling smart devices. So all these have to also be encrypted, so only then they can interact with the system. So security plays a very major role, that too in this era where we are attacked with many hacking systems, and many things are there to enter into the system. So how do we handle this? So security is one software module. It is not a kind of a hardware or something. It's just software module which is spread across for all the modules. So some features which under this module would be debug port protection. There normally every hardware would have a debug port just to debug if something is wrong to it. So this will be normally be totally disabled when it goes for the manufacturing, or it will be at least be password protected. And interfaces to this port, like software interfaces to this, would always be an authorized one, so unauthorized access will not be there. Then secure bootloader. Software would only boot, or only if there is a authentic way or a method, like only when ignition is done, only then you press the key or something, only then it will load. So those kind of rules would be set. Then for secure data storage, if we are storing any data, like every system would have its own memory. So when we want to store it, so we have to make sure that sensitive data is not saved, or personal data is not saved, and everything will have its own authentication mechanism. securing internal software applications. Yeah, okay, each, like I said, media, radio, so these are applications that are placed in a system. So how do we security has to be made for these individual applications as well. Normally it is done through any of these kind of keys or a password kind of design would be there for correct uh, for these applications. Then removing debug content, yeah, normally softwares, we when it goes for the manufacturing, the binary units, binary what we flash on the systems will not be having any debug way, so that we don't have any there's no possibility of reverse engineering. Communication. Yeah, communication is again for the Ethernet connection, communication, or any device communication. Protocols are there which will tell this is an authenticated kind of data which is coming in or no. And the last would be for all the kind of security that we handle here, there's always a validation and certification which is done. For example, if I take Apple device being connected to our system, it is even our system, even media center is vulnerable to the information, and even the phone is vulnerable to the information that is exchanged. So normally what happens is the Apple as an organization will give us a certification that our software is well enough secured to handle the Apple phone. So these kind of certifications are there for each of the devices that we handle. So at every step we have a validation and certification done, so that we have really have an security for our systems and all the connecting systems as well. This is how the just a brief on how the security is handled. Okay, yeah, this is some appendix that I have added. Okay, references. I've given few YouTube links, and one this I wanted to show. One BOSH page. So you can. This is a main page where all professional systems are listed, and details of each of these can also be seen. So just wanted to, this is infotainment systems which I talk about. So the other systems which does not involve HMI much, connectivity control unit, digital vision system, which I told, replacing our cameras, mirrors with the cameras. So this is BOSH page which talks about other professional systems as well. And since this system is already in the market, it's already I mean, you can go to Google or YouTube, and if you say just a coach infotainment series, then you will get a few videos also which can help you to understand the system. So that's from my side for this session. If you have any questions, I am happy to take it.